software security maturity frameworks provide guidelines and practices to help organizations develop more secure software. They are an excellent resource to help organizations optimize their focus on the most impactful practices they could be incorporating. Various of the practices they outline empower developers to build secure software from the ground up. But there is still one crucial element missing to help these developers. Security maturity frameworks can be descriptive, like BSIM, Building Security in Maturity Model, which offers real-world security practices done by actual organizations for your organization to benchmark against. Alternatively, these frameworks can be prescriptive and provide specific guidance for organizations to follow. Some commonly known prescriptive frameworks are the OWASP Software Assurance Maturity Model, SAM, the NIST's Secure Software Development Framework, SSDF, Microsoft's Secure Development Lifecycle, SDL, and the International Organization for Standards, so ISO 27001. These frameworks typically cover practices across different domains, such as governance, development, testing, and releasing. BSIM and SAM offer different levels of maturity for each practice. For example, in BSIM, in the code review domain, the first level of maturity includes the use of automated tools. The second level of maturity mentions using tailored rules for these tools. And the final level of maturity includes things like the capacity to eradicate bugs completely and enforcing secure coding standards. The other frameworks don't use different levels. They simply assess whether a practice is incorporated into an organization or not. For practices specifically addressing developers and secure code production, there are two main sets of practices. First, in the governance or preparation domain, frameworks recommend on-demand and role-specific training. For developers, role-specific training means providing defensive and solution-oriented training that focuses on efficient and framework-specific, project-specific remediation. Contrary to security professionals, learning how to attack or exploit code is actually secondary to most developers. The second set of practices is implemented during the design and implementation phase. Frameworks often suggest practices for developers such as using secure by design components, using approved security features and frameworks and patterns, and always adhering to secure coding standards. These recommendations can be summarized as using secure guardrails, sometimes called the secure defaults or paved road security. And this approach should simplify development and reduce the risk of vulnerabilities being introduced due to misconfigurations, due to a lack of knowledge or inattention. So by offering built-in security, developers can focus on their main task, which is developing feature, and at the same time maintaining high security standards. But to help developers apply these practices, frameworks recommend tools and technologies that support secure development practices. Remember how in the second maturity level of BSIM, it mentions the use of tailored rules with security tools? This is very clear and a practical guideline to benchmark against. Are you tailoring your rules or are you not? But for the third level, it mentions the capability to eradicate bugs, which sounds more like a goal than a practice. You see, in reality, developers are often handed repurposed security tools intended for security professionals. These traditional security tools rely on a reactive approach. They scan completed code for vulnerabilities, and they provide feedback too late, which slows down deployment and release cycles. But if we can provide role-specific training, we can provide role-specific tools. To encourage organizations to adopt a secure defaults approach and reach that highest level of security maturity, we must show them how to empower their developers. I have researched which features improve usability for developers and can make security tools truly developer-friendly. First of all, they must be fast, as in almost real-time fast. They should be well integrated into development workflows, preferably in the IDE, as research shows that is where developers prefer to go back to fix problems in their code. It should be easy to customize and adaptable to each developer's preferences. Enabling them to determine what's a useful and tolerable level of feedback is still preferable. If a developer can easily turn off 99% of the markings and feedback, that is still preferred to getting no markings at all because they outright disable the tool or completely ignore it. But most importantly, the tool should help developers fix problems. All of these security maturity frameworks say you should be offering tailored rules, but we should also be offering tailored solutions that can be applied effortlessly, much like a spell checker or a linter. So while software security maturity frameworks recommend adopting a shift-left approach and adopting secure guardrail practices, they do not specifically suggest role-specific developer tools. But I think a genuine developer-first tool can make a significant difference in adopting these practices and should be given more consideration. To learn more about this topic, subscribe to my future videos.